Recording started.
Okay, we're going to review how to convert from an exponential equation to a logarithmic equation and vice versa. Now I've got the definition of logarithms up here to remind you how they are related. The definition is that if you have log with any base b of a number m equals n, that's true if and only if the base raised to the n power equals m. Now I'm going to point out a few things that might help you when you're converting from these equations. The base in the log is always the same as the base of the equation. So these two numbers are always the same. Okay? Now, the logarithm always equals the exponent. So this number will always be the exponent. So this is the exponent. Okay? And then the third number is the value that we're taking the log of. So that's what it equals. So I'm just going to highlight that in green. So these two are going to be the same. All right, but the base and the exponent should be easy to do. Now, I'm going to start with a few in exponential form because I think that's what we're most familiar with. We're going to do some that we know, and I'm going to convert them to log form. So for this exercise, we're going to go from exponential form to log form is what we're doing. Is we're converting from exponential form to log form. Okay? So let's start off with something we know the exponent of. So let's do, say, for example, 2 to the third power equals 8. Okay? All right, so if I want to change that to log form, I'm going to have log, and I'm going to color code these. Okay? The base of the exponent is 2. So that's the base of the log, and that's written as a subscript. The exponent itself is 3. Okay? So that's what the log is going to equal. The log always equals the exponent. And then the third number is 8. So log base 2 of 8 is going to equal 3. Okay, and that was where the 8 came from. It turns the exponential form around. Okay? All right, let's do another one that we might be familiar with. Let's do 3 to the negative 2 power is 1/9. Negative 2 power is 1/9. Okay, so once again, I'm going to color code these. It's just going to be log, and the base is 3, so that's going to be the base of my log. Okay, the exponent is always what the log equals, so that's going to equal negative 2, and the third number is the 1/9, and that goes right here. Okay, now let's do one that's just a little arbitrary. Let's do y, change the color, y to the z power equals 9. Okay? So that's going to convert to log. Now once again, the base is y, so that's the base of my logarithm. The exponent is what the log equals, so it's going to equal z, and that's going to be log base y of 9 equals z. Okay, and that was actually one from the test. Now, let's do a little bit more practice so I can point out a few other things. Let's take, for example, exponential form. Let's do 10 to the x equals, say, 4.2. Okay? So log form is going to be log base 10, that's the base, and the log always equals the exponent, so that equals x, and 4.2 is what we're taking the log of. So that's going to, log base 10 of 4.2 equals the exponent x. Now, the one thing that I wanted to remind you of is that when the base is 10, we don't need it. So this is properly written. Let me type that out. Properly written as log with no base, because it's understood to be base 10 when there is no base. Properly written, that would just be log of 4.2, and that equals x. That would be the proper way to write that, because when it's base 10, we don't really need to include that base. It's understood to be base 10 when we write log with no base. Okay. Also, if I have, for example, e to the 2x equals, say, 7.5, then when I change that to log form, that's log, and then this is going to be base e, and it's going to equal the exponent of 2x, so that's what it equals. Equals 2x, and we're taking the log base e of the 7.5, so that's log form. Now, because that's log base e, we don't generally write that log base e either, so properly written, we know that log base e is written as ln. So properly written, that would be ln. Now I'm going to use a lowercase l, ln of 7.5. So we drop the e and indicate that as ln. So that's understood to be log base e, and that equals 2x. Okay? So that's several examples of how to change from exponential form to logarithmic form. Now let's do the reverse of that. Let's do some logarithmic form to exponential form. Alright, so let's take a log. Let's do log base 3 of 27 equals 3. You know what? Let's change that slightly. That way it's more clear. Log base 3 of 81 is 4, because I wanted to use 3 different values. Okay, now, once again, let's color code this. The base of the log, that's your base, it's written as a subscript, is the base of the exponent. What the log equals will always be the exponent, so that's 3 to the 4th power, and that's going to equal the 81. Okay. Let's take a look at another one. Let's do log base 5 of 0.04 equals -2. Okay? Alright, so the base is 5. That's going to be the base of my exponential form. The exponent is what the log equals. Logs always equal exponents, so that's going to be -2. 5 raised to the -2 power is 0.04. Okay? Alright, now, suppose I have just written log of x equals 3. Okay? If there's no base here, no base with log means the base is understood to be 10. So it might help you to pencil that in. Okay? So we would take, I'm going to go ahead and write it, I'm going to color code it. So since it's spelled out log, that's going to be base 10. Log base 10 of x equals 3. So that means that's the base of my exponent, 10. The exponent is going to be to the third power, and that equals the third value, this x here. So 10 to the third equals x. There's always 3 parts to everything. There's the base, the exponent, and then the third number, what it equals. Okay? All right? Now let's take a look. Let's try 1 or 2 more. Let's do ln of x squared equals -2, for example. Okay? Now once again, this log has no base. So in this case, if it's ln, excuse me, no base with ln, means the base is understood to be e. Okay? So you might want to pencil that in to remind you. So I'm going to put that in right here. E. So that means when I write it in exponential form, that is the base. The log always equals the exponent. So that's going to be e to the -2. And the only thing we haven't used at this point is the third thing. This is this x squared. So e to the -2 is going to equal x squared. All right, so if we do one last one from one of the ones from the test, very similar to what we've been working on. This was one of the problems from the actual test. It said convert to an exponential equation, and it was log 18 equals 1.2553. Okay, so once again, this one has no base, but it's spelled log, so that's understood to be base 10. So when I write it in exponential form, that's going to be base 10. 10 is the base, and what the log equals is always the exponent. So that's 1.2553, and that is going to equal our third value, which is 18.